Hey there everybody, in this video we're going to be talking about solving systems of equations with three variables. Now I'm just going to give you the heads up right out the gate here. These problems take a lot of time, and if you make a mistake at some point, you're probably not going to realize it until the very end of the problem, and that's super frustrating. I completely understand that, but I'm asking, please be patient when you do these problems, and please take your time when you go through. I'll share with you a few little shortcuts as I'm going through them, and then I'll also kind of share with you a few things to look out for when you get into your Math Excel assignment later on for homework. There are going to be two additional videos beyond this one that kind of go more in depth for substitution and elimination, so they'll kind of separate those two processes. Me personally, with these problems, I almost always stick with elimination. However, there are very few times where substitution will be the go-to method. So let's take a look at our little warm-up here. Here we have three different scales. So I've got two boxes of A and one box of B. I've got one box of C, three boxes of A, and then a box of a B and a C, and that's paired up with a 10-pound weight. So I've got three different scenarios essentially, and I want to figure out how much does each box weigh. So I'm trying to figure out what is the weight of box A, what is the weight of box B, and box C. All right, well, let's see what they give us. For the first scenario, I'm saying 2 A boxes is the same as 1 B box. So I could safely say 2A equals 1B. Similar logic. I know that 1 C box is equal to 3 A boxes because those kind of balance each other out there. And then lastly, I've got a B and a C combined, so that would be B plus C, and that's going to equal 10. So this is going to be one of the few scenarios in which substitution is actually going to be our friend for these problems, because I've got three separate equations, 1, 2, and 3. But since I've got some variables isolated by themselves, so I have B equals stuff, and then C equals stuff, this is where it's going to be kind of advantageous for me to plug in to other equations using substitution. So I know that B is equal to 2A, so in place of B, I can throw in 2A. And I know that C is equal to 3A, so in place of C, I can throw in a 3A. So when we do that, I'll write under here, we're going to have 2A plus 3A, and that's going to equal 10, so 5A equals 10. Therefore, A is 2. Cool. Well, now we can figure out B fairly quickly, right? If A is 2, I can plug in 2 there, and I can plug in 2 there. So I'll get B is equal to 2 times 2, that's 4. And then C would be equal to 6. Right? Not too shabs. All right, so let's see a gross problem, shall we? Here we go. Icky. If you guys need to pause the video here to write this down, that is not going to be a bad move. So here I've got three separate variables, which means I have I have at least three equations. So however many variables you have to have at least that many equations. The first equation I'm looking at, x plus y plus 2z equals 3. That seems like it's going to be pretty user-friendly, right? Because there's no coefficients on my x and my y, so I could do some elimination right there fairly easily if I wanted to. Second equation, we've got a 2x, a y, and a 3z. I'm noticing here the y is the only thing that does not have a coefficient. The x and the z does, so I'm probably not going to want to multiply this equation by numbers if I don't have to. And then our last one here, it looks like the x and the z, those would be pretty easily eliminated here. All right, so my goal when we're solving these is you're going to start off with 3 equations and 3 variables. And then we're going to do some elimination, right? We're going to whittle this down until you have 2 equations and 2 variables. And then you're going to do your plain old substitution elimination from there until it's just 1 equation and 1 variable. And once that's all done, you can go through and solve and work your way back. All right, so first ones, let's see. I'm going to focus on getting rid of, I'm going to get rid of the x's. So my job is going to be eliminating the x's, just because I'm noticing that this doesn't have a coefficient, this doesn't have a coefficient, so it should be pretty straightforward. So my first step is going to be eliminating the x's. All right, let's see. So I'm going to take the first equation and the third equation. So I'll take those and I'll just do some straight up elimination on there. X's cancel, that's what we want. I have a negative y plus 3z, and that's going to equal 13. Cool. Let's see. If I did the first equation and the second equation, I could eliminate the x's again if I multiplied everything from that first equation by maybe a negative 2. So if I did that, let's see, I'm multiplying everything in that first equation by negative 2. So this would be negative 2x minus 2y minus 4z equals negative 6. So now I can kind of ignore that guy. All right, when we combine those, x's cancel, that's what I wanted. I've got negative y minus z equals 1. All right, so let's kind of take a step back what we've done. We started off, we had 3 equations, 3 variables, and now I've eliminated x, so now I've got 2 equations with only 2 variables. So the equations that I have now are negative y plus 3z equals 13, and negative y minus z equals 1. I'm going to try to clean things up and rewrite those down here. Again, sorry as always for the junky penmanship. I'm writing on an iPad. It's not the easiest thing in the world here. All right, so I've got negative y plus 3z equals 13, and then negative y minus z equals 1. All right, well, I'm thinking if I just get rid of the y's here, right, that should be a pretty easy elimination. Really, all I'd have to do is just make one of those positive. So I'm going to go through and I'm just going to change everything in this bottom equation to a positive or negative. I'm going to flip it to the opposite. Essentially, I'm multiplying by negative 1 when I do that. So let's see, this would be a positive y. And then we'd have plus z, and that's going to equal the negative 1. So now the y's cancel. Good. And I'm getting 4z equals 12. Therefore, z is going to be 3. Woof. Okay. So now the hard part is done. Working our way to get that very first variable is the hard part. So we've gone through this process, right? 3 equations, 2 equations, 1 equation. We've solved this 1 equation, 1 variable, and now we're going to kind of climb our way back up. So I'm going to use z to figure out another variable. Well, I can plug in z, which was 3. My equal sign got all wonky. There we go. I can plug in that 3 value right here for z. Or heck, I could have even done it right here if I really wanted to. In fact, I think I'm going to do this second equation here just because I don't like negatives if I can avoid them. All right, so we would have y plus 3 equals negative 1. I'd subtract 3 over, so y is going to equal -4. All right, so I've got 2 out of the 3 variables figured out. And now I just need to pick any random equation from the originals to plug these into. I'm thinking that first one looks pretty user-friendly. So let's see if I can get that first guy. Get some plagiarism going. All right, so we don't know x. We just discovered that y was -4. And 2z, if z is 3, that'd be 6. All right, so as we continue to solve, I'd get x plus 2 equals 3. Therefore, x equals 1. Now, when we write our answers, we always want to write them out as an ordered triple if we are dealing with x, y, and z variables. So in this case, it's going to be 1, comma, -4, comma, 3. And if I did this correctly, I should be able to take all of these variables and plug them back into my original system for every single equation, and we should have a valid solution. So I should plug in 1, -4, and 3. 1 minus 4 plus 6, yeah, that's going to be 3. 2 times 1 is 2. Minus 4, we're at -2. Plus 3 times 3 is 9. -2 plus 9 is 7. That checks out. -1 minus -8, if I plugged in -4, so that'd be plus 8. So -1 plus 8 is 7. Plus 3, yep, is 10. So this all checks out. This right here is going to be our final answer. Now, as promised, I said I'd share with you like a few tricks as we go through. I'm going to skip ahead some of these examples. And we're just going to kind of start this one off. And I think once you see the pattern, it'll start to clarify. And then from there, if you want to hammer out the remaining problem, you'll be more than welcome to. But again, there are additional videos that go further in depth for substitution versus elimination. All right, so for this example, and if you need to pause to write it down, pause to write it down. I'm noticing this last equation is missing a y. So if this is missing a y already, it's already down to 2 variables. I'm going to kind of keep that and set it aside. And then I'm going to take the other 2, and I'm going to work with those. And my goal is to try to eliminate the y's. So that's what I'm going to end up doing here. All right, so if I multiply that top equation, see, I'd have to multiply everything by 3. I would get 6x minus 3y plus 3z equals -6. And then we can just take that second equation for face value. Don't have to do anything to that. So when we get all that done, we'll have 7x, y's cancel, plus 2z equals 4. So 7x plus 2z, and what was it, 4? Yeah, 4. So now this system right here would be pretty quick and easy to solve. So if you're sitting there thinking, how come this problem only took us like 1 minute to get this far, and the other one took us what felt like forever? The reason it is because I was able to use that little shortcut. And some of us might have been tempted to say like, hey, we can cancel out those z's right away. Yeah, if you cancel out the z's, you're left with an x and a y, and then that's going to be tough to incorporate that third equation down in there. So little patterns like that will definitely come into play here. And it will be in your best interest to keep an eye out for those, so that way you're not wasting your time going through these. All right, that's all I'm going to go through on this video. Don't forget, your homework or your assignment is going to be Unit 1, Day 8. It's not going to be a long assignment because these problems take a while, so there's not going to be a whole lot of problems. But just please be patient when you go through. Please take your time, and don't be afraid to write out using a lot of paper. All right, that's all I've got. You know the drill. Any questions, please let me know. Good luck. Have fun. Be safe. Roll Tide.